Hey folks, welcome back to another code walkthrough video. In this video, I'll be discussing about RAQA with Langchain. I am Shubham Agnihotri and you're watching the beginning of infinity. So let's get started. So directly I'll come on to the code and yes. So the code is divided in basically 3 to 4 segments. Where we download the data, then we upload the data to a vector database, and then we use Langchain to perform that retrieval from the database, and then we use Chainlit as a UI for the user to interact with it. So uh, coming on to the code, so over here we are using Selenium to download the data set. So these are basically, it's basically to scrape the data set. So over here, when we go on to the URL, which is here, where is it? Huh. So this is what the URL looks like. So this was for Shawshank Redemption. There were some issues onto the Selenium end from my end, so it was not really running for a really long time. So I kind of went back and did it for Barbie, but I'll show you what exactly we're extracting. So if we go on to inspect, so that is how even we do it. So you can see there is a container onto the right. Then you see there is there has to be review container. Yes, this is the review container, right? So coming on to the code. So this is exactly what we are looking for, which is a review container. So we are looking, and this is a load trigger more. So what is this load trigger more? It's basically, once we scroll down, we have a load button. So there are, every page has around 25, reviews. So it is to load more and more, and we are sleeping it so that the more files get kind of loaded in. So what is the header count? It's basically, scrolling back up, this is the total number of reviews. So this is the total number of review count, which is over here, the header span, extracting this and then doing how many number of pages will be there, because number of pages in the sense we have one page of 25 reviews, so accordingly. Then what we do is basically we scrape it, then what we do is we segregate the data. We have meta information like title, review date, ratings, attributes, various other things, and we also have our actual text. That is what we store it in a data frame, and we save that. So once the data is ready, now it's the task of now we have the data ready. Now what we need to do is we need to chunk the data and store it in a vector store. So earlier we did it, we created our own vector store. Right now we'll be using Pinecone for doing it. So over here we have a recursive text splitter. Similarly, we are doing a text splitter. Generally, it happens, it splits based on slash and splits on new lines. So we have kept the size of 1000 and chunk overlap of 200. We are going for length. So this is the index that we created. There is a Pinecone API for which we are interacting it. Then we are creating an index. We are using cosine similarity and dimension of 1536. Why 1536? Because OpenAI embeddings give us the dimension of 1536. If we were using Hugging Face some model, so generally it is, I guess, 768. But again, it depends model to model. So we are here. We are creating an index, and so this is the index where we'll be populating the data. So if I show you the index, this is how it looks like. So we have created a project, we have the API key, we have created an index, and now here is where we'll be populating all our values. Like as you can see, we have all the meta information that we stored uh, over here in our code, which was above here. Now here exactly, sorry, this one. So this is the absurd thing, but yeah, this is the data frame, and then what we do is basically we are using a caching as mechanism as well. So we are creating a local file cache. So right now what over here we're doing is, from the data frame data that we have, we are saying, okay, this is what the metadata looks like. This is the actual value is what looks like, and we are keeping a batch of 100. So basically once 100 reviews are done, then that is where we do an upsert command, which you can see over here. So upsert is basically update or insert. It's basically, if the file is present, then update it. If it's not, then insert it. So so this is just uploading onto the data frame, uploading onto the vector store. So now once we have uploaded, we just need to do a Q&A. So for Q&A, what we need is we need a vector store. We need to tell the LLM where we are looking the data from. So we say, okay, ChatGPT, this is the vector store that we are looking at. So index is again the index that we created, which is this value, and then query.embed embedder.query. So it is basically looking, we have a cache over here. So for example, I ask how was the movie. So if this cache was already there, we don't need to embed it again, right? So that is basically saving couple of API calls. And field text is text, so generally it'll be in a form of a text coming in. So now we have a query, like, I'm really enjoyed this movie, I'm not target audience, but blah 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 blah. And then we are checking the similarity. So vector store gives us a similarity. And so this just to check whether vector store is actually working fine or not. Now coming on to let me check, are we timing it? No, we are not. On this one we are timing it out. So now is basically a QA chain. So over here we are using a retrieval QA chain by Langchain to do our basically asking questions and getting the results out, rather than doing a similarity search. And so basically in the backend it uses similarity search. It gives us 545 documents and then uses 45 documents as you can call it as a context, and then gives back an output. I'll show you in 1B how it is working. So standard out callback scheduler, it's basically to handle callbacks. Standard output is basically it is used for handling. Then we have a basic LLM is ChatGPT. A vector store is our pinecone. Return source document, yes, we want from where exactly it has been used. And then what we do is we query it, saying, okay, how was Will Ferrell in this movie? So I guess this is from Barbie movie, if I recall it correctly. So yes, how was Will Ferrell in this movie is what I had asked it. According to the first piece of context, the user mentioned the Will Ferrell ruined every scene on it. Okay, so this was one review that came in, and we are storing everything with in tracking everything in WNB. So if we look at, can I run this right now? It's a first query. Okay, leave it. So because we are using cache, right? So it's a kind of a in-memory word-to-word match cache. So if you the first query, you can definitely have this notebook. I'll be sharing it along, so you can download it to a star mark on it and run it, and you can check the time difference. The first query will take around a second time, where this one will be 1/3 of a second because it has already cached it. So yes, so this is how the implementation of it in Hugging Face looks like. I'll walk you through on the Chainlit application as well. Let me see how is it working. How was the movie? Let me check. What does this guy say? The movie was super pleasantly impressive and the best one the user has seen. Okay, so quite positive feedback. So let's see how does our this tracing looks like. So we'll see what are the things that the model has considered. So let me check. Yes, so the first question was how was Ferrell wheel in this movie. So if we see, it has gone with a retrieval Q&A chain, and we can see this was a query, this was the result. These are the source documents that were given to it. So it's a very overall level. So now let's type a bit more deeper into it. So so retrieval QA chain internally called stuffed document chain, where again, see, here are the documents that we are sending in. So there is top k value is 4, 1, 2, 3, and 4. These 4 values are basically the most similar ones that have been matched. Then what happens is we are summarizing the context of all these 4 values together. So if you say no very realistic, don't make me laugh, it has to be somewhere. Yes, no very realistic, don't make me laugh. Yes. So it is combining all of them into one context, and then it is giving it to the OpenAI. It says, use the following piece of context as the user for the user question. If you don't answer, you don't just say don't know. And this is the question, and that is how the output was generated, and that is what it has been retrieved back. Similarly, for this one, if we go and check, oops, yeah. So if we go and check, so if you see how many documents were there were 4 documents again from the movie, and then they combined the context and gave us the output. So coming on to Chainlit UI, very simple, very straightforward. Initializing Pinecone environment, like again, a lot of it has been taken from the notebook. You'll also find the app file over there. So on start, what we're doing is we are creating a cache, we are loading the vector store, we are loading the LLM, we are creating a chain, we are passing the chain over here. Once that is done, we are basically just asking the user to give an input. So folks, that brings us the end to our walkthrough. I hope you guys enjoyed it. You guys took something back from it, and if you do like this content, please do share with your friends. It'll really help the channel. Do like, share, and subscribe. Till then, take care, stay safe. I'll be back soon with another video. Bye bye.